Geometry, Geometric, and Spatial Reasoning Standard 4.2. The slope formula is a measure of the steepness of a line. We should be familiar with the slope formula. The distance of y values and distance of x values, or rise over run as you've heard it. We also need to remember that parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. Also helpful here is the distance and midpoint formulas. The distance tells how far apart 2 points are on a coordinate plane. The midpoint finds the halfway point when you're going from one point in the direction of another. A parallelogram is a special kind of quadrilateral. Quadrilateral is a four-sided polygon. Parallelogram is a four-sided polygon such that both pair of opposite sides are parallel. So in this picture we see segment AB is parallel to segment CD. Those are called opposite sides. They don't touch, they don't share a vertex. Segment AD is parallel to segment BC as well. Okay, so we don't have just the one, we have both pair of opposite sides parallel. In all parallelograms, the diagonals bisect each other. That means they share a midpoint or cut each other in half. So plot 4 points and prove the shapes of parallelogram. We've already plotted the points. Realize for point A, for example, make sure you go over first and then up. So 2, 4 is in this position here, for example. Now we can go for different things here. We could just find 2 midpoints and show that the diagonals bisect each other. But what we'll do instead here is go for the 4 slopes, because 4 slopes helps you with both parallelogram and with the next quadrilateral. Okay, so for the slope of AB, I first use the formula. Here's A, here's B. The 2 y coordinates, which are on top of the fraction, is 4 and 1, so 4 minus 1. And the 2 x coordinates in the same order are 2 and 4. You do need to make sure to go in the same order. Since I started with A, with the y coordinate, I'm going to start with A for the x coordinate. When you do the figuring here, it's -3/2. No surprise, we're going downhill there. The opposite side of segment AB is segment CD. And you can see the calculations here. Again, the y coordinates on top, -3 and 0. And in the same order, the x coordinates are 1 and -1. Okay, because these match, I've shown that 2 of those sides, one pair of opposite sides, segment AB and segment CD, are parallel because they have the same slope. We must also do it for the other pair of opposite sides. Now here it's easier generally just to count off the slope instead of using the formula. Neither technique is difficult, but counting the slope is more efficient. To do that, take the leftmost point of the 2. So for AD, for example, D is to the left of A, so I start there. I count up or down and then to the right. So from D, I go 1, 2, 3, 4 up, and 1, 2, 3 over. The slope is 4/3. For segment BC, C is leftmost, so I go up 1, 2, 3, 4 over 1, 2, 3. Because I have both pair of opposite sides parallel, I've shown that I have a parallelogram. Rectangle is a parallelogram that has 4 congruent angles, or 4 right angles if you prefer. In a rectangle, the diagonals are congruent, and they'll bisect each other since a rectangle is a parallelogram. I'm missing an L there. But we're going to go for the slopes again. It's the easiest way generally to prove on a coordinate plane. So here's another one. Plot the points. Again, if we find all 4, we'll notice something happening here. So here's segment EF, up 1/4. Segment GH, same thing. We have one pair of parallel sides. Segment FG, down 4/1, so it's negative. It's -4. Segment EH, same thing. Not only do we have 2 pair of parallel sides because we have 2 matching slopes there, but we've also shown that we have a lot of perpendiculars, okay, because 1/4 is the opposite reciprocal of -4. Because we have this combination of 2 pair and the 2 pair are opposite reciprocals of one another, we've shown it's a rectangle. Okay, if it's 2 pair and they're not opposite reciprocals of one another, then it's just a general parallelogram. It's at least not a rectangle. Okay, so that's the extra part that we can show for the rectangle. Now you could also go for diagonals congruent, but you'd also have to show other things because there's something called an isosceles trapezoid that has diagonals congruent, so that wouldn't quite be enough. Let's look at rhombus. A rhombus is a parallelogram that has 4 congruent sides. In a rhombus, the diagonals are perpendicular. So we have a choice here. We could, because all 4 sides are congruent, we could just go for 4 distance formulas and show that all 4 distances are the same. What's probably a little easier though is to go for the diagonals. Okay, so here's a rhombus that's already plotted. If we find the segment AC, again, we're just going to count here from this point forward. So down 4 over 12, we have a negative 1/3 slope there. And then for BD is 6/2. So again, notice we're going for the diagonals this time, not the sides. Going for opposite corners here. Okay, so negative 1/3 and 3. These are clearly perpendicular. They're opposite reciprocals of one another. Negative 1/3 and positive 3 over 1. But now, just because they're perpendicular, that's not sufficient. It could be something called a kite, which is another shape that's not a rhombus. So we need to also show that the diagonals bisect each other. Okay, so to do that, I'm going to find the midpoint. So AC, the midpoint would be the halfway point there, 3, negative 1. So what I did is took the 2x coordinates, averaged them, the 2y coordinates, averaged them, and did my math here to get 3, negative 1. If I do BD, I find it has the same midpoint. Okay, so they're intersecting there, and because it's the midpoint, they are bisecting each other. So for a rhombus, I could go for the 4 sides and use 4 distances, or I could do the slope and midpoint of each diagonal. Let's finish with a square. A square is a parallelogram. It's also a rhombus and a rectangle. And rhombuses and rectangles usually are different, but when they're the same thing, they're a square. It's the only case where they're the same thing. So in a square, diagonals are perpendicular and congruent, and they bisect each other, all those things. So for this square, what we're going to go for again is the diagonals would be the easiest here, because if we go for the sides, then we'd have to show we have to go distances, and we'd have to go all the slopes. It would be a lot, but diagonals are more efficient here. So we're going to go from A to T. That's this one here. And notice something funny here. Our slope is undefined. We have a 0 on the bottom. That indicates that we have a vertical line. Okay, you go from A to T. Now this could be a 6 or it could be a negative 6. It's up or down, whichever. But in either case, you're going over 0, so it's undefined. If you do PR, straight across. Okay, I'm not going up any, but I'm going over 6 units. Undefined and 0, that's a vertical line, horizontal line. Those are perpendicular. Okay, so we've shown that we've got a rhombus here, or actually, we've shown that the diagonals are perpendicular. Not quite enough to show us a rhombus, but if we know it's a parallelogram, it would be a rhombus. But let's also go for them being congruent, and if we can do that, we've got ourselves a square. Okay, so let's use the distance formula for the first time. Okay, the distance formula takes the 2x coordinates. This is AT. Notice distance, remember, has no segment over the top. So we've got the 2x coordinates. So for A and C, they're both 1s. And the 2y coordinates, 4 and negative 2. Well, 1 minus 1 is 0. 4 minus negative 2 is 6. So eventually we get 6 here. So the distance is 6. Now, granted, this being a vertical line, I could have just counted. But usually, if it's at a slant, you can't do that. Now, I'm going to use a shortcut here because it's straight across. I can just count. The PR is also 6. So because our diagonals are both perpendicular and congruent, it would be easy to show that that must be a square. Okay, I don't have to show diagonals bisect each other. They do, but that would just be overkill and not necessary. Okay, so to summarize, for a parallelogram, you could either go for midpoints of both diagonals, or you could find the slope of all 4 sides to show that you have 2 pair. For a rectangle, the easiest way is to go for all 4 slopes and show that you not only have a pair, but the 2 pairs are opposite reciprocals. For a diagonal, for a rhombus rather, you have 2 choices. Just go 4 distance formulas on the sides, or show that the diagonals both bisect each other and are perpendicular. In a square, it's easiest to go for diagonals being both congruent and perpendicular. The standard says to classify quadrilaterals in the coordinate plane by proving simple geometric theorems algebraically.